There is a specific phenomenon people experience when they first truly test the limits of modern artificial intelligence. They ask it a complex question, receive a shockingly creative answer, and end up losing 3 sleepless nights experimenting with it. The shock comes from a realization of behavior. ChatGPT doesn't operate like traditional software. You put in a prompt, and you get a different answer every time. It acts like a person. Wharton professor Ethan Mollick argues that this represents a new category of interaction. We are essentially learning to communicate with an alien mind. This forces a change in how we use our tools. We can no longer rely on rigid instruction sets. We have to learn how to collaborate with a system that possesses its own unpredictable intuition. Economists call tools that touch every industry general-purpose technologies, or GPTs. Historically, these required decades of infrastructure to mature. Early computers sat in massive rooms for years before trickling down to individual desks. ChatGPT reached 100 million users almost instantly, requiring 0 new hardware for the public to adopt. It also targets a different sector of the economy. Past automation, like the steam engine, replaced repetitive physical labor. This wave explicitly targets highly compensated, highly educated, cognitive work. Technology has historically taken generations to integrate from the bottom up. This is arriving in months from the top down. For decades, artificial intelligence research focused on solving strict logic puzzles or navigating physical mazes. The turning point arrived in 2017 with a new architecture called the transformer. It gave computers an attention mechanism, allowing the software to weigh the contextual importance of different words in a sentence, rather than just reading them rigidly left to right. This enabled unsupervised pre-training. Instead of relying on humans to label data, the AI ingests billions of unstructured words from the internet. It organizes them into a massive network of mathematical weights that encode exactly how language connects. Using those weights, the system calculates the probability of what the next word in a sequence should be, with shocking accuracy. Humans then step in to fine-tune the model, rewarding good answers and penalizing bad ones. This transforms a raw text predictor into an aligned, conversational agent. The final product actively generates original, contextually rich content based entirely on statistical intuition. Because it relies on probability rather than rigid programming, the software is unpredictable. It can easily find solutions to complex problems and, in the next breath, confidently hallucinate entirely false facts. We are left with a paradox. The AI excels at creative human tasks like parsing legal arguments, while frequently failing at basic machine tasks like precise math. In 1950, Alan Turing theorized that if a machine could fool a human through conversation, it exhibited intelligence. Today's language models pass the Turing test easily, leading researchers to document sparks of general intelligence. And those capabilities are compounding. In under a year, image generators evolved from creating distorted, chaotic textures to producing photorealistic accuracy. We are navigating a jagged frontier of capabilities. The line separating what the machine can do flawlessly from what it cannot do at all is invisible, and it moves every single day. This chart shows the scale of the impact. The steam engine boosted factory productivity by 18 to 22%. Early studies on AI show a 20 to 80% improvement in cognitive tasks. This increase creates an effect called the Great Leveler. Looking at the curve on this same chart, we see where gains occur. AI drastically boosts the output of lowest-skilled workers, closing the gap between struggling and excellent employees. This equalizing effect has already been documented across elite professions, from corporate law to management consulting. As a result, a phenomenon known as secret cyborgs is emerging. Workers are utilizing AI to cut hours of tedious tasks down to minutes, but they hide these gains from their bosses out of fear they'll be penalized. The economic baseline has shifted. Output no longer relies solely on individual human brainpower. It relies on the synergy between human and artificial intelligence. Researchers generally point to 3 possible trajectories. First is the as-is scenario. Even if AI development freezes today, the existing tools are capable enough to displace or augment massive sectors of the workforce. Second is slow growth. If progress hits a wall and slows to a linear pace, we will have time to retrain. In this scenario, we already see AI beginning to analyze past research papers to find scientific directions humans missed, or autonomously conducting experiments. Finally, exponential growth. If these models continue compounding, we reach artificial general intelligence. AI physicists and economists are already using the technology to accomplish research in days that used to take years, suggesting a future where AI handles the bulk of our complex discovery. This opens the door to a eucatastrophe, a joyous turn of events where the machine's ability to find proofs and experiments restarts the engines of progress. Because this technology is brand new, there is no central authority or official instruction manual to guide you through the transition. Ethan Mollick argues your best strategy comes down to one rule: always invite AI to the table. Barring ethical or legal restrictions, use it for every task you do. Actively experimenting with this co-intelligence is the only way to map its jagged edges and protect your future productivity.